Good being on.
All right, guys, welcome. And maybe we should start off with a brief presentation, a brief introduction to each of you, since not everyone in the audience might know who you are and what you're doing. So ladies first, Melonee, what are you doing? What is your company doing?
Yeah, thank you. Fetch Robotics makes collaborative and autonomous robots for the logistics industry. So we make mobile robots, or, well, actually they're platforms that you can create accessories and augment to do picking activities. So when you buy something from Amazon or you order a product online, our robots help do that.
So it's actually a robot that follows you through the storage room to pick up the package, or?
Yeah, so we do last mile delivery within a facility. So when you're doing the picking activity, our robot will come with you. It'll follow you through the warehouse, and then you can take the goods, put it in the robot, and as you're almost done with an order, that robot goes away and a new robot appears. And so you never actually have to leave the area where you're picking goods.
Eric, what do you do?
So we are a maker company. We provide open hardware technology and agile manufacturing services. So we are calling ourselves the T side of IoT. We help people to embed more technology into objects around us.
So you're into rapid prototyping and stuff like that?
Yeah, we also help you to prototype, manufacture, and distribute.
And what do you actually build, robots or Internet of Things, or what kind of hardware do you build?
We actually provide all the technologies like supermarket. So our customers, makers, startups, they use our technology to build all kinds of things from drones, wearables, IoT, smart home, everything. Yeah.
And last man on the left, or no, on the right. You're on the right.
Yeah.
Sorry. Derrick, what do you do? You brought something with you.
Yeah, so we are Yihang. I'm the co-founder. So Yihang is a company making drones. We talk so much about drones today, and we make intelligent, smarter drones. Especially one product we launched this year early in Las Vegas in CES was this Yihang 184, which is a passenger-size self-piloting drone or self-driving drone in the air. We call it AAV, Autonomous Aerial Vehicle. We're also making drones that could, like what she said, solve the last mile problem. We're also making drones for the transportation of the human-made organs for transplant patients as well. And this is the smaller consumer drone we have today. It's it's called a Ghost drone, and we'll talk about that later.
We'll get back to that drone later.
Yeah.
Since this is a panel about artificial intelligence, I would like to ask you, because you're all doing hardware, so could you actually see hardware as a physical representation of the software, as a physical representation of artificial intelligence in the physical world? What do you think, Melonee? Do you consider your robot to be something like that?
Well, robots are just computers wrapped in plastic. There shouldn't be any confusion about that. Really, robots are a physical vehicle for a computer. And if you want to talk about what robots are, they really are any computer that can touch and interact with the real world. And I think that the core side of our business is software engineering. More than 50% of the engineers we have on staff are software engineers. And so we're very, very heavy on the software development.
So software is really a big part of your robots?
Yeah, robots are kind of useless without software.
Yeah. Eric, you do Internet of Things. How big a part, the software must be a really big part of that.
Yeah. So in the very beginning, we start from bottom up. We provide all the circuits, all the sensors, brains of the hardware. But then we realized that you have a much better soul to control and interact with different devices. So we are closing the gap from the other end. And we see in the future, it's not only just a connected artificial intelligence thing, but it's like a swarm AI. Each of the devices is very limited. It can have 1 year's intelligence, but combined together, they have some social layer work to build up the synergy and collaborations. That could be a very beneficial AI system.
So it's sort of like a smart layer on top of the physical world?
That's right. We're actually seeing more internet companies, software teams, they're expanding their API to the real world. So it's like just the same thing controlling the button on the screen, but you're controlling something which is a physical object.
And Derrick, I noticed you don't have any controller with you. Or you do have something there with some
Yeah, I do
antennas.
have something
I mean,
here.
how does it actually work? I mean,
Sure. So the
and
AI.
how big a part is software in this setup?
Exactly. So software for us is the fundamental, is the key. It's the most important thing. It's the most, it's the essence. Why is that? Because we found that most of the drones, even today, 99% of the drones are controlled by those very traditional radio controllers. And so 2 years ago, we kind of thought through this, and we want to say, well, you know what? We think the future trend is going to be smartphone. Everyone has a smartphone. And every single smartphone going to have this calculation capability to control anything. So what we do is that we use smartphone and to control this drone. And then it's all about software. And at the same time, we're also combining these like a VR technology together with a smartphone controlled drone, make it easier. So what we are trying to do is we're trying to lower the barriers of controlling for mass consumers, and this is why we're having this. So one of the typical AI, I would say in general, drones today are still way early, in the AI world. It's just like, it's just like the first day. It's really early. Most of the companies just solve the problem of this like a basic flight control algorithm, meaning that even if you go back to like 3 years ago, there are still a huge portion of drones you couldn't really fly it stably in the air for a long time. That was the problem we just managed to solve for among the industry. So now it's just getting a little bit better. Some application like what we do is like we build up the software that kind of calculates the minimum battery levels for the drones in order for it to come back, in order for it to fly back, or the sufficient battery level in order for it to fly back. This is the kind of the very simple thing we do. And in future, we're seeing great opportunities in the computer vision part, to give an eye for the drone. But if you talk about those kind of typical AI scenarios that people are gonna say, wow, is this drone is gonna, bite people? We think that's still kind of far away. Smart enough? No.
Melonee, do you consider your robots to be sort of intelligent?
Yeah, that's always a funny question. So robots today probably have the intelligence of 3-year-olds, maybe. You're lucky if they can recognize faces. I would say that when you look at AI in general, AI typically uses some kind of reinforcement learning, which in my industry is not safe. Because for every reinforcement, you need a positive and a negative example, and a negative example is typically killing someone or going into the men's bathroom or something you don't want it to do. So a lot of times when you talk about learning in the context of robots, especially things where safety is important or critical, you talk about supervised learning. And we use supervised learning in the practical application of our robots in the methodology of like motion primitives. So say you want a robot to go from here to the other side of the room, you can create a graph, and a lot of people, what they call that is an experience graph, and across that experience graph you can use what are called predefined motion primitives to execute local trajectories. So if you are executing from there to there, you don't know what's going to be out past 25 meters, because in our case that's the range of the laser. But as you get to a region where you see an obstacle, you then execute a motion primitive around that obstacle. And so that's where we bring in some learning, but it's not learning in the big AI sense of, oh my God, it's taking over the world and going to eat your babies. I don't know. I mean, that's just one of those things, Robots aren't that intelligent.
Eric, when it comes to Internet of Things, I mean, they're sort of invisible to the human eye. So will this sort of look more like artificial intelligence, or your surroundings becoming intelligent, or sort of like magic in a Harry Potter way, or?
Yeah, I think after many years, we see things around us. They might still look the same, but they have some embedded sensors, computations, connections. But I think the AI is not necessary to be in the cloud. It's not a vertical only. It's also expanding. You have things around you, they're connecting, they have their behaviors. So we see another intelligent, they're starting from smart things. We connect it. That's the very first step. They only have the behavior of itself, but then we link different behavior together that actually creating the context. we're creating the applications for some specific scenario. That's where their AI is growing up, growing from 1 year, 2 years old, 3 years old to robotics. But only we have more devices connected. They become a synergy. We can have a superset of human beings. The more AI we have from the devices, the human beings could be more beneficial or have a terrible end.
So you have all touched upon AI not being dangerous. It's not going to be something like that will eat your babies or whatever. But will AI become something completely different than humans? I mean, will it turn up in a form that we didn't anticipate?
I'm sure it will. I mean, if you give any system long enough to execute, given a learning algorithm, say a probabilistic algorithm, there's a couple things that can happen. One, it goes in a direction you didn't expect. It eats itself, so it just it could not converge. I mean, that happens. Algorithms don't always converge into what you expect. It may just barf. I mean, it doesn't have to work, right? And so I think that expecting an outcome on a typically probabilistic model, that's typically where you see intelligence. You have to have some noise to create something that looks like people, because we are random and serendipitous. Then you may not get what you want, and that's the facts of it. I mean, otherwise you're making deterministic systems, and you know what the outcomes are.
Any comments from you?
Yeah, I think these, like back to the point that's how we see the growing, in the drone industry, how we actually grow AI in the drone industry. I totally agree with Eric that there was a point that when we talk about Internet of Things, it's not just about horizontal, it's not just about what's happening on the ground. It's also about vertical, meaning that drones actually could be seen as one of the, kind of like the connector in the sky that's going to connect, that's going to collect data. Also connect different devices or data in the air. That's also the kind of thing that we're doing that in order to make drones smarter, because in the air, today we're more talking about drones carrying a camera that just for people to do aerial filming to capture great footage. But in future, what is even much, much bigger than this consumers market is the commercial drone market. Meaning that today, there's a company collecting data, collecting like a 3D modeling, or a company making drones that's for agriculture, or a company make drones, or a company who's making operating system for drones in order to kind of get the drone, compatible with different kind of different accessories or systems in the air. This is definitely one of the, I would say, the emerging way that how we growing, how we get the drone smarter and smarter in the future.
Sorry?
So I was thinking that people worry about AI because you don't know what's it like. It's in the future. It's not ready yet. It sounds scary because it can outplay you on Go. Does not mean it can ever kill you. Because we are so cared about the danger of AI. So we will have the means to, fence it under our control. It's like the nuclear bombs. You know how dangerous it is, but you are under control of it. But I think the real problem is from some area that we don't know is going to be danger, and they will come out to have some menace to real human being leakages. People can hack a computer. They can also very easily hack into IoT. But what is the drives to hack and or to protect? I think that will both develop. I'm very positive about AI because as the technology grows, a new means will fix all the dangers that are created by the new technologies.
So you think that if you do create a dangerous AI, or that's something that will create problems in the future, you will solve these problems along the way?
I think it's very natural that you create a new AI could counteract with bad AI to defend it. But I think it's still far beyond us to worry about. For now, all these AI, they are like very little insects.
So does this mean that you don't pay attention to the current debate on AI, that people are afraid that we would create dangerous AI when you do your robots? You don't pay attention to it, or you don't mind about it?
I actually think it's a whole bunch of fear mongering for no reason. To be perfectly honest, I think that the idea that some computer system is going to become sentient in the next 10 to 20 years is almost laughable. And the idea that it would have the ability to create extreme impact on the physical world is even more interesting, because you have to give it the access for it to do that. And I can't imagine why you would give any system physical access to something that could kill large amounts of people. And so that's a societal choice, not so much AI running amok, because you'd have to give that system physical access to do something very bad. And at the scale of like an automaton, like a person scale thing, I mean, it would be very hard for any kind of physical robot today to basically walk up the stairs, much less get a gun and fire it at me. I mean, in fact, roboticists are actively working against not doing activities like that. DARPA had a project 5 years ago called the DARPA Arm Project, and when they put in the prospectus that the robot arm would have to pick up a gun, every roboticist was like, nope, sorry, not my bag of candy. And then the DARPA organizers came back and they were like, well, what if it's a drill? And everyone was like, well, maybe we could pick up a drill. But still, I think that when you look at things like this, people are not comfortable with the idea of giving organizations the power to do harm with these physical things. It will happen, but you still have to give them access.
What is your opinion on regulation on this area, regulation about robots or drones? I mean, drones that's a field which is being heavily regulated, and people are very worried about what drones can do and not do.
Yeah, regarding the regulation part, I think currently there's kind of this like a global fear about drones, because it just like seem to interrupt like people's privacy at the same time. It's just like a crash everywhere. This is due because we are in the early stage of the AI, or because drones are not smart enough. That's why it crashes all the time. So we're pretty optimistic, because if you look back in the history, that if one thing you wanted to grow instead of just wanted to be banned by the government, the most important factor is that how much productivity can you actually improve for the societies among the different industries. Most people see drones as consumer's toy, but we see drone as a great tool helping people in different kind of industry inspections, agriculture, surveillance, like 3D modeling. It just like saved tons of hours, that have to be done by human beings. So, as long as this is, proved to be true, we have a really optimistic, attitude towards the future for drones.
Eric, do you see regulation of Internet of Things as a threat to your business?
It's never happening. I think the only regulation we are facing is about the radio frequencies, like FCC, the CE certificates. For now, I think the Internet of Things is still very, very naive stage. It's not there yet. They are not going to harm our life. It's like just our appliances. Do you need a license for a refrigerator? No, it's not yet. But I think if it goes on, these things collaborated, they have much stronger intelligence. I think the most important way to prevent the risks are registration. It's like you have a car, you can kill people with your car. But you have the plate, you are taking the responsibility of its behavior. The owner, the user, should be take care of that. Then it's still too early to set up a rule and to form up the regulations. I think there's a lot of progresses. Whenever we have the problem, we fix the problem. So you don't debug whenever there is no bug.
So that was the last word from us on the AI subject. I mean, it seems like you don't worry too much about artificial intelligence, and we will fix the problems along the way.
Yeah.
Thank you, Derrick. Thank you, Eric. Thank you, Melonee, for coming here and enlightening us on this subject. Thank you.
Thank you.
Thank you.